So we have seen the wave polarization in the last lecture. Now in this lecture we are going to see power flow and Pointing vector. Okay. So we'll start with the Maxwell's equation first. So del cross E vector is minus dB vector divided by dt. We have studied this Maxwell's equation. This is one of the time varying Maxwell equation. This can be written as, so I can replace B with mu h. So this becomes dH vector divided by dt. We have to do a small derivation over here, and it is important to study this derivation because then only you will appreciate the uh, pointing vectors. Then only you will understand the concept behind this. Okay. Next, del cross H vector is J plus d vector by dt. Here you can write this as, okay, J is nothing but sigma E plus d can be replaced with epsilon E. So this becomes epsilon dE vector divided by dt. Now what I'll do is, there is an identity, there is a vector identity. The vector identity says that, so vector identity, the vector identity is del dot A vector cross B vector is equal to B vector dot del cross A vector minus A vector dot del cross B vector. This is one of the vector identities. Now we will make use of this vector identity over here. So what I'll do is, I'll find del dot E vector cross H vector. What is del dot E cross H? So it is H vector dot del cross E vector minus E vector dot del cross H vector. Now we have the values of del cross E as well as del cross H. So let's just substitute it over here. So I'll get H vector dot del cross E is minus mu dH vector divided by dt minus E vector dot, we have sigma E vector plus epsilon dE vector divided by dt. So this is del cross H. Now this can be written as, so if you take the dot product of these two, so you will get dot, once you take the dot product, you will not get the vector signs, because dot product will result you a scalar quantity. Now so you will get minus mu. Now here this will become, I can write this as mu by 2 dH square by dt. Just differentiate this and you observe that you will get the same quantity again. If you differentiate this, you will get 2h dH by dt, right? So if you differentiate this, just let me write it over here. So 1 by 2 dH square by dt. If you differentiate this, you will get 2h dH by dt. So 2 and 2 get cancelled. So you will get h dH by dt. The same thing which you will get here. So therefore, I can modify this as in this way. Now minus E dot sigma E will become sigma E square, and this will become in the similar fashion what we have done over here. In the similar manner, I'll get epsilon by 2 d into E square by dt, right? Now just let me rearrange these terms. So I'll get del dot E vector cross H vector is equal to minus d by dt mu into H square by 2 plus epsilon into E square by 2 minus sigma into E square. So what I have done, I have just rearranged the terms. Now I'll take volume integral on both sides, because what I can do is I can apply divergence theorem over here. It is del dot. So if I take volume integral on both sides, I can apply the divergence theorem over here. So if I take volume integral both sides, I'll get, so taking volume integral, I'll get del dot E vector cross H vector into dv is equal to, here I'll get minus d by dt. What I've done, I'll take this uh, partial differentiation outside the integral, so it will become complete differentiation. Integration of 1 by 2 mu into h square plus 1 by 2 epsilon into e square. So this is one term into dv minus integral sigma e square into dv. Okay, now I can write this equation again as, this can be written as, so this is del dot a into dv. So I can write this as E vector cross H vector into ds is equal to minus d by dt integration of 1 by 2 mu into h square plus 1 by 2 into epsilon e square dv minus integral of sigma e square dv. Now we need to understand the meaning of all these terms. What does this gives? This is nothing but the total power leaving the volume. This gives me the total power leaving the volume, and this is nothing but, now half mu h square is nothing but energy stored in the magnetic field, whereas half epsilon e square is nothing but energy stored in the electric field. So this will give me, so this is nothing but total energy stored in the volume, stored in volume, complete volume. And since there is a negative sign over here with differentiation, so this is nothing but, this complete term is nothing but the rate of decrease of total stored energy, rate of decrease of total stored energy. And this is nothing but the ohmic power losses. and rate of decrease of energy is nothing but, again, it is power. So this entire term, these both the terms, they are giving you the total power loss. So this is giving you the power loss. Rate of change of energy is nothing but power. So this complete right hand side is giving me the power loss from the volume. So obviously, if you have to equate both the sides, then this must give you the power leaving. Obviously, this is some quantity which is leaving the volume. That is for sure, because you have divergence over here. You have divergence over here. So obviously, this quantity is leaving the volume. Now, to equate the uh, s- um, to satisfy this equation, if this is denoting the power, the right hand side is indicating power, then left hand side must also be a power. And since you have divergence over here, it is obvious that this is the power leaving the volume. Now, why this is power, it will be proved. I'll prove it. This E cross H, let us check the dimensions of E cross H. Now this is nothing but Pointing theorem. This is called as Pointing theorem, that power leaving the volume is equal to power loss. And here this E vector cross H vector, if you check its dimensions, so the dimension of the dimension of electric field is volt per meter, and the dimension of H vector is ampere per meter. So this becomes volt ampere per meter square, and volt ampere is nothing but watt. So watts per meter square, which is nothing but power density. And this is denoted by a vector called P vector, which is called as Pointing vector. So this is called as Pointing's vector, which represents the power density, which gives power density, that is power per unit area. I hope this is understood. E cross H denotes watts per meter square, which is nothing but power density, and it is denoted by a vector P vector, which is called as Pointing's vector. Now, this, what is the direction of P vector? It is E cross H. So we have already seen that in TEM waves, in the transverse electromagnetic waves, the wave direction is given by E cross H. So obviously, the direction of power and the direction of wave are one and the same. So the direction of power flow is in the wave direction. This is quite obvious, because the direction in which wave will travel, power must be in the same direction. Now, this is called as power density. So we have defined a new term over here called, which is called as power density, and we are calling that as Pointing's vector. Now we will define the instantaneous and average Pointing vectors. Okay, so this equation P vector is equal to E vector cross H vector will help me. Now I'll start with, so what I'm doing here is I'm trying to find instantaneous and average Pointing vector. These are very important because questions are frequently being asked from this topic. So let me consider E vector is equal to some E naught into e power minus alpha z cos of omega t minus beta z into ax vector. So I have considered a very general case, in which I am assuming that there is attenuation. Attenuation is there. I am not considering a special case. So I am considering a general case in which attenuation is also present. Now we know that we have seen that E naught by H naught is nothing but intrinsic impedance eta, and eta is in general a complex quantity. We have seen this. Eta is complex. For example, for a good conductor case, eta, there was a phase difference of 45 degrees between the electric field and the magnetic field. So in general, this eta, this intrinsic impedance is a complex quantity. So therefore, what will be H naught from this? H naught will be E naught divided by eta. And since it is a complex quantity, so what I'll do is I'll convert this into phasor form. So I'll consider this as E naught divided by mod of eta into angle of eta. Now I can calculate H vector from this. So H vector will be, magnitude of H will be this now. So E naught divided by mod of eta. This magnitude will be here, but this phase will be added in the phase of magnetic field. So this will become e power minus alpha z cos omega t minus beta z, and this angle will be added in this. So this will become this, if you take it in the numerator, this will becomes minus theta eta into ay vector. Magnetic field obviously will be in the y direction because wave is in z direction and electric field is in the x direction. Now I've got the magnitude, the values for E vector as well as H vector, expression for both of them. Now I can find the instantaneous power. So P vector is equal to, we have already seen this, E vector cross H vector. So if you substitute this and solve for the, so you will get E naught square divided by mod of eta e power minus 2 alpha z cos omega t minus beta z into cos omega t minus beta z minus theta eta into az direction, because we know that pointing vector is in the direction of wave. This is called as instantaneous pointing vector. This is called as instantaneous pointing vector. It is not of great significance. The significance is for average power. So P average. This instantaneous pointing vector is used to find the average pointing vector. So average pointing vector is 1 by t integration 0 to t p vector dt. So over a time interval, over a period I have taken this. Now cos A cos B can be written as cos A plus B plus cos A minus B. So if you apply that formula, you will get the result. I'm directly writing the result now. I'm not going into the detail of derivations. You just substitute P vector over here and just integrate this. So you will get P average vector is equal to E naught square divided by 2 times mod of eta e power minus 2 alpha z into cos theta eta az vector. So if you need the help, just what I've done is, so how to solve this, what you will do is you expand this. So cos A cos B will give you, I'll just give you the hint over here. So cos A cos B will give you two terms. One term will be cos A plus B. So when you add both of them, you will get cos 2 times omega t minus 2 times beta z minus theta eta. This is one term. and the second term will be cos A minus B. So when you subtract both of them, you will get cos of theta eta. So you'll get one term as this and the second term as this. Now, when you integrate this over a time interval over a period, so you know that the average value of cosine is 0. So this will not give you anything. But this is a constant, this is not time dependent. So this will not give you a 0 result, and hence you are getting this term in the average power. So in this way we have got the expression for average power. Now, now this is a very general case. Now if I consider a special case of perfect dielectric or free space. So for free space or perfect dielectric, we know that the electric field and magnetic field, they are in phase. That means this theta eta is 0 degrees. So for perfect dielectric or free space medium, alpha will be 0 because we know that there is no attenuation in those two mediums. Also theta eta is also 0 because electric field and magnetic field are in phase in that case. So therefore my P average will become E naught square divided by 2 times mod of eta into AZ vector. This is very important formula. Or you can write it in terms of H naught, H naught also. So in that case it will become H naught square mod of eta, because we know that E naught is equal to H naught into eta. So divided by 2 into AZ vector. These two are very important formulas, and I have seen you observe, if you look at the previous year gate question papers, you will surely observe one question on this. There are many questions actually on this. Now there is one more formula for P average, and that is P average is equal to, this is also very important, 1 by 2 real of E vector cross H conjugate vector. This can also be used to find the average power. So this is all about the power flow and Pointing vector. Here the important things are the Pointing vector and its direction, and also this average power. These are very important. Just let us solve one or two problems based on this. So let me consider this problem. So it is given that in a non-magnetic medium, electric field E vector is equal to 4 sine 2 pi into 10 to the power 7 t minus 0.8 x into AZ vector volt per meter. What we have to do is, we have to find option A, epsilon r comma eta, bit A. The second bit is the time average pointing power, the time average power carried by the wave. Now since you observe in the wave equation, the electric field is given to us, so there is no attenuation. So therefore the medium must be a perfect dielectric or free space. Also we observe here that the velocity, just check the velocity. So omega and beta are given to me. So with the help of omega and beta, so velocity is omega divided by beta. This I know. So omega by beta will give me, omega is 2 pi into 10 to the power 7 divided by 0.8. So this velocity is obviously less than 3 into 10 to the power 8, and therefore the medium is perfect dielectric. It's not free space. For free space, the velocity must be 3 into 10 to the power 8. If it is less than that, then it must be a perfect dielectric. So since velocity is less than 3 into 10 to the power 8, or the velocity of speed of light, therefore the medium must be a perfect dielectric. Okay. Now you can find the epsilon r value. So beta is given to me. So beta is, we know that it's omega into under root mu naught into epsilon, and this implies beta is equal to omega into under root mu naught into epsilon naught into epsilon r. Now beta is given to me, beta is known, omega is known, and mu naught into epsilon naught is also known. So you can easily find the value of epsilon r. Now, so just solve it. You will get under root of epsilon r is equal to beta by omega 1 by under root mu naught into epsilon naught. So beta is, how much is beta? So if you solve this, you will get, okay, beta is 0.8 divided by 2 pi into 10 to the power 7 into 3 into 10 to the power 8. So if you solve this, you will get ultimately epsilon r is equal to 14.59. This is the value of epsilon r. Also, we have to find the intrinsic impedance. So for perfect dielectric, we know that intrinsic impedance is 120 pi divided by under root epsilon r. So here actually, if you solve for under root epsilon r, it is 12 by pi. So if you substitute 12 by pi over here, so it's 120 pi divided by 12 by pi. So it's 10 into pi square, which comes out to be 98.7 ohms. So this is the intrinsic impedance for this medium. Next, so bit A is over. Next, similarly, when next we have to find the time average power. So we have to find P average. So P average will be E naught square divided by 2 eta, and since the wave is traveling in x direction, so its direction must be ax vector. What is the magnitude of electric field? It is 4. So 4 into 4 divided by 2 into, we have just now found the value of eta. It's 10 into pi square into ax vector, which comes out to be 81 ax vector milliwatt per meter square. So this is the average power. So this is an example. Let me consider one more problem. Here H vector is given to me as 5 root 3 divided by eta naught cos omega t minus beta z into ax vector plus 5 by eta naught sine omega t minus beta z plus pi by 2 ay vector in free space. We have to find the time average power density. Okay. So again, we know that since it is given, the magnetic field is given. So therefore, P average is it's E naught square divided by 2 times mod of eta, and the wave is traveling in z direction, so it is az vector, or it is equal to h naught square into mod of eta divided by 2 into az vector. Now I can easily find h naught over here. Just take the so h naught will be equal to under root of it's 5 root 3 by eta naught square plus 5 by eta naught whole square. So h naught comes out to be h naught square comes out to be, this is 25 3 is 75, 75 divided by eta naught square plus 25 divided by eta naught square. So this comes out to be 100 divided by eta naught square under root. Now since free space, so I'll make it eta naught. Eta naught is 120 ohms, 120 pi ohms. Okay. Now I need the value of h naught square. So h naught square will be 100 divided by eta naught square. And the power average power vector will be equal to this value h naught square. We have 2 in the denominator into eta naught. This many times az cap. This cancels. So it is 50 by eta naught into az vector. So this kind of simple questions are being asked in the gate also. So once you are clear with the fundamentals, it is very easy to solve such problems. So this finishes the Pointing theorem. This is very important. Please pay attention to this, and the questions being asked are very easy. They are straightforward. You can solve them very easily. And the important points are the Pointing vector and the average power. Mostly the question being asked are on these two topics.